If you look at the productivity of an automobile in the form of miles per gallon of gasoline, you're getting some information about how efficient the automobile is, but only in one dimension. There are other resources that an automobile uses up in doing what it does, and those things have to be taken into account in understanding the efficiency of the automobile. One way of addressing this is to find a common denominator to measure all of the resources that go into running the automobile and compare that to the output. And that might be the cost per mile of operating the automobile. Translate that now to evaluating projects that we might undertake in a university. And we have to look at them holistically and look at all of the resources that go in and all of the outputs. Dollars as a common denominator are a very helpful metric, but they don't tell the whole story. There are many intangible benefits that come from undertaking an initiative, and those too have to be recognized. They may not be easily quantifiable, but they have to sort of sit on the score sheet of, is it worth doing something? Let me give you a couple of examples from projects that have gone on campus at UIC. The Wellfield project that was used for Lincoln Douglas and Grant Halls. If you look at it from a return on investment perspective, the payback period may be over 100 years. It doesn't necessarily reduce energy consumption by an amount equivalent to the cost of doing it. On the other hand, what it does do is create 12-month temperature control in buildings. And for those of you who live in our centrally heated and cooled buildings and are very uncomfortable in what are called the collar months, the spring and the fall, you'll know what I mean. So that's a benefit that goes into it. Similarly, let's use the photovoltaic cells. Whether they have a positive return on investment or not, in terms of energy utilization, is only one factor. The impact of putting photovoltaic cells on a roof, and a roof that might have to be replaced, and the cost of the maintenance of the roof has to go into the analysis. So it's a matter of looking at things holistically. Let me end with one more example. The energy-saving contracts that we're negotiating now that are to put new heating and ventilating equipment in the science buildings on the south side of the East Campus, and they could conceivably, now this may sound ironic, result in the use of more energy. Why? The cheapest way of operating a building is not to have the fans in the heating systems operate. It costs you zero, both in dollar terms and in terms of the energy utilization. So again, if you use a more holistic analysis, we may wind up spending more money and using more energy. But whether or not that is a worthwhile endeavor really depends on looking at the benefits holistically. The health benefits that come from having ventilation operate effectively in a science facility is a very, very important benefit. So, let me just leave you with the thought, don't look at things simplistically and focus on only one dimension of the problem, but look at it holistically, include both the quantifiable and non-quantifiable benefits in the analysis.